Now let's quickly go over some of the basics of DynamoDB. First, the DynamoDB terminology comparison with SQL. So in SQL, we have tables. In DynamoDB as well, we have tables. The only difference is in SQL, we can have tables within a database, while DynamoDB tables are top-level entities. So in DynamoDB, we don't have a concept of database. Then in SQL, we have rows and columns, and in DynamoDB, we have items and attributes instead. Primary keys in SQL databases or relational databases can be on multiple columns and they are optional, but in DynamoDB, primary keys are mandatory and we can have one or maximum two attributes in the primary key. So we can either have a partition key or we can have a combination of partition key and a sort key. And primary keys being mandatory is one of the reasons that helps DynamoDB deliver consistent high performance at any scale. Then in relational databases, we have indexes. In DynamoDB, we call them local secondary indexes. Similarly, in relational databases, we have views, and in DynamoDB, we have global secondary indexes instead. Now, DynamoDB tables are the top-level entities in DynamoDB, so we don't have a concept of databases, and there are no inter-table relationships in DynamoDB. The tables are always independent of each other. This allows us to control the performance at the table level. So you can control the performance of your tables independent of other tables in your account. DynamoDB table items are stored as JSON, DynamoDB specific JSON to be precise, and we have seen it in the hands-on demo. Then primary keys are mandatory. Rest of the schema is flexible. So the only attributes that are mandatory are the primary key attributes, and rest of the attributes are optional and you can add or remove them at runtime as and when you like. Primary key can be simple or composite. Simple primary key means the primary key is composed of only the partition key. Partition key is also called as hash key, and composite key has two attributes, partition key and a sort key. Sort key is also known as a range key sometimes. And non-key attributes, including the attributes that are part of the secondary indexes, are always optional. So here's an example of a simple primary key. So it only has a partition key and rest of the attributes are optional. And this is an example of a composite primary key. So we have primary key composed of a partition key and a sort key, while rest of the attributes are optional. Then data types in DynamoDB. So there are three categories of data types that are supported in DynamoDB. First is the scalar types. This means you have one key and one value per key. Key is the attribute name, while value is the value of the attribute. So we have exactly one value. Examples are string, number, binary, boolean, and null. And keys or index attributes only support three scalar types, that's string, number, and binary. So if you're using any attributes as primary keys or the attributes of the secondary indexes, then those attributes can only be strings, numbers, or binary. The second category is set types. So here we have one key and multiple values. So you can think of this as arrays. For example, you can have string set, number set, and a binary set. So you can have an array of strings, array of numbers, or an array of binary values. And the third category is document types. These are simply the complex JSON structures with nested attributes. Examples are list and a map. You can simply think of the document types as nested JSON documents. And finally, let's quickly look at the AWS Global Infrastructure. Now, this is not specific to DynamoDB, but I'm using it to help you understand how DynamoDB ensures high availability. So we have the AWS Cloud, and AWS Cloud has different AWS regions across the globe. So we have multiple regions, and each region has multiple availability zones. An availability zone is a geographically separate area within an AWS region. So a region can have multiple availability zones, and each availability zone can then have multiple data centers. So here we have multiple data centers in different availability zones. And DynamoDB automatically replicates your data between multiple facilities within AWS regions. So it basically puts your data into at least 3 different facilities within different availability zones. For example, when we create a new table, the table data is automatically replicated across at least 3 different facilities. And this is a real-time replication. And this allows DynamoDB to offer high availability as the AZs act as independent failure domains. So here we have data replicated across at least 3 different data centers within multiple availability zones.